Salt, or specifically sodium chloride. It's the only rock that we eat, the unlikely joining of a poisonous gas and an explosive metal. And when paired with water, it provides both the incubator and ingredients for life. We use sodium and chloride ions to keep our cells inflated, to regulate blood pressure, and convey electrical nerve impulses throughout our body. To maintain this, we need to consume about 6 grams of sodium chloride every day. So, salt's culinary and cultural value is no surprise. Its history could fill a book, and it has. It's a great book, by the way. Have you guys read the book Salt, A World History?
Yeah.
Salt, such an obvious, almost mundane element, ends up being absolutely essential to the functioning of the human body. Our muscles don't work without salt. Our nerves can't transmit electricity. Ultimately, our heart will stop without salt as our blood pressure drops to 0. It's vital for human life.
Also, salt is essential for muscle control, neurotransmissions, and maintaining a proper fluid balance. And a low salt presence in blood means hyponatremia, a condition which can include nausea, headaches, fatigue, heart problems, and other lovely symptoms like that.
Or 7 tablespoons.
Salt is an electrolyte that keeps our cells, muscles, and nervous system working. Because when you come right down to it, we run on electricity. Electrolytes act as the electrical conductor that allows our nerve endings to fire, our muscles to move, and our thoughts to form.
Well, the human body is actually a machine. It's an electrical machine, and electrical impulses move into and out of the cells over the cell membranes, and that transmission is facilitated by the sodium.
If that's true, could salt water act as a conductor, connecting 2 electrodes, lighting this light bulb? Pure water doesn't complete the electrical circuit.
I'm going to add a small amount of household salt. Goes the stir bar, and there is the light. As it goes into solution, the water separates the sodium and the chloride ions, and they allow the electrons to flow from one side to the other, completing the circuit, lighting our light bulb.
All our bodily fluids are salty because salt and water are inherently attracted to each other.
For our well-being and very survival, salt is essential.
Salt is necessary for life as we know it.
As human beings, we're electric bodies. You need salt for your very synapses to fire.
Nerve cells throughout your body send electrical signals when they receive a stimulus.
Whenever electric current flows down a nerve cell, there's an influx and outflow of sodium ions.
The electric properties of animal bodies were first discovered in the 18th century by Luigi Galvani.
Luigi Galvani found that when he took the leg of a dead frog and sparked that frog leg with some static electricity, the leg began to quiver.
Scientists later discovered that many human body functions are electric, including the heartbeat.
Salt regulates and drives the phenomenon known as the action potentials that keeps our heart going.
When it comes to medicine, salt is a prominent feature of countless medical treatments throughout history.
One of the earliest pharmacology books was published by a Chinese emperor in 2700 BCE. It had 40 different medical treatments that involved salt.
The healing powers of salt were also celebrated in the works of the ancient Greek physician Hippocrates, and by the medieval Islamic physician known in the West as Avicenna.
Avicenna's book, The Canon of Medicine, was used well into the 18th century, and it established a lot of the medical practices that are still used today. And many of Avicenna's treatments relied on salt.
One of the most common and effective treatments in modern medicine is a simple salt-water mixture known as saline solution.
This diluted and sterile salt water is used to replace bodily fluids, which is important for treating things like dehydration and other ailments.
One of our first lines of defense against pathogens or infections when we're in, for example, a pandemic or exposed to any type of pathogenic organism.
Now, As we reach the final phase of our thought experiment, we strip away the vital role of salt in health, hygiene, and medicine.
If we suddenly lost the cleaning properties of salt-based soaps, human diseases would go unchecked.
Take away salt from the field of medicine and life expectancies plummet.
And as salt within our bloodstream begins to break down, our bodies stop functioning.
If the salt in our bodies disappeared, our muscles and organs couldn't operate properly.
Just a few salts are regulating how and when our heart beats and controls pretty much life or death.
As our thought experiment reaches its terrifying conclusion, things become incredibly dire around the world and for this group of friends.
Without the salt in our body, we would be in mortal danger.
We'd be doomed.
In our thought experiment, this group of friends and the entire world have suffered greatly as salt was stripped away from medicine.
Without salt, we would all have heart attacks.
Industry.
Salt plays a pivotal role in the production of material that we use in our everyday lives.
The environment.
Salt regulates movement of the ocean currents.
And our food.
Salt makes food resistant to rot and decay.
The life-saving benefits of salt continue to push the boundaries of modern medicine.
Redox signaling science is basically a very new field. It's only been around for about 10 years. Scientists are gradually getting involved with redox signaling because they realize that it's such a fundamental process in human physiology. Plants and animals and lower forms of life and all forms of life use redox signaling messengers in order to repair themselves. Let me explain a little bit how that works. When a cell becomes damaged, there are certain messengers that are set out. It's called oxidative stress messengers. Those messengers then are able to tell the tissue that something is wrong. The tissue then is able to respond to that by a variety of different methods. It'll increase antioxidant production, for example, and efficacy. It will try to repair itself. If it's not able to repair itself, then the cell will actually end up killing itself and be replaced by other surrounding healthy cells. This is a remarkable process because it is actually the process which allows us to regenerate tissue and maintain our health. Damaged cells need to be detected. They need to be either repaired or replaced. And so this protection, detection, repair, and replace mechanism is absolutely fundamental to all life. So one of the interesting aspects of this discovery is that we've actually learned how to take these same redox signaling compounds that exist inside our cells and produce them in stable form outside our cells. A stable form that has shelf lives of months. And so then this signaling compound can have the kind of bioactivity that has been played out in our scientific investigations. And we actually see the fruition of such. We see, for example, that cells in cultures, in laboratories, are able to increase the antioxidant efficiencies, for example. Cells are able to elicit different responses that are involved in this repair, replace, and detect mechanism that allows us to regenerate tissue and heal ourselves, basically. And we're actually seeing real evidences, or at least anecdotal evidences, that these things are taking place. At that point, I realized that this is real. It's true. It's happening. And this technology needs to be distributed as far and wide and as quickly as possible. This became almost my cause a cause for me in a way, because this redox signaling molecules in the system had so much potential, so much great potential to help people on this planet. And I almost felt as if I was given this technology, and that this kind of was coming together almost on its own volition, if you will. It is extremely potent. The idea or the possibility of being able to stabilize redox signaling molecules and use them as bioactive, non-toxic agents inside our body is phenomenal. And it will make a difference, and it will be the future technology that will affect almost all areas of health science and well-being.